Alright, so this is Chapter 8, Section 6, Cry Not. That's the last section we'll cover this semester. Cry not. Our learning objective is to solve rational equations and to use rational equations to solve problems. To solve an equation containing rational expressions, we're actually going to highlight this because multiply each side by the least common denominator. Remember all that stuff we did yesterday? This is why we're doing it. Doing this, however, can introduce extraneous solutions. That's kind of that might pop up in a essential question. So let's make note of the extraneous solutions. A rational equation contains at least one rational expression. You can simplify solving a rational equation if you first clear the equation of denominators, which is why we multiply both sides by the least common denominator. You can do this by multiplying by the LCD of the rational expressions in the equation. Here's a couple examples. A rational equation looks like this: x over x plus 1 plus x over x minus 1 equals 2 over x squared minus 1. Not a rational equation. This guy, he does not have a polynomial in the denominator in any of the components, so he does not get to be a rational equation. Anytime you multiply each side of an equation by an algebraic expression, it is possible to introduce an extraneous solutions. What do we do if we have an extraneous solution? It's what you guys are going to do at the end of the semester. You're going to do. Okay. What do you do at the end of the semester? Take a final. It's also called a. You take one at the end of every chapter.
End of chapter review.
Test. So you test. You're going to test for an extraneous solution. So once you find your answers, so x equals 4 and 12, you have to plug them back into the original equation and test them. So an extraneous solution is a solution of the derived equation, but not a solution of the original equation. You must check all solutions of the original equation to confirm that they are indeed solutions. So make sure you include testing the solutions, because it's going to be, this is super easy to do to you on a multiple choice even. Which ones are solutions? They throw out the two, but if you don't test them and realize that one of them is not a true solution, then you'll get that wrong. And I don't want you to get it wrong, I want you to get 100% right. So let's do two different type of problems. Oh goodness gracious, you're super lucky. If you look at A, the denominator for both of our expressions is x plus 2. So we're going to multiply the top and the bottom by x plus 2 on each side. No, I'm just going to multiply the top by x plus 2 on each side. So when you do that, x plus 2's cancel, and I get x minus 1 equals x squared plus 2x minus 3. This is a nice quadratic equation. Oh, remember when we did the 8 equations? Let's see. We are going to put all of our items on one side so that 0 is on the other. That means we're going to minus an x and add a 1. So we get 0 equals x squared plus 1x minus 2. And then we're going to go ahead and factor this side, so we get 0 equals which two terms? Multiply to give you negative 2 and add to give you 1. Well, we need a positive 2 and a negative 1. We take those two solutions, x plus 2, set each one equal to 0. And we find that our two solutions are x equals negative 2 and x equals 1. We need to test both of those. I can already tell you one of them is a no bueno. What happens to this, to my original expression when I put in -2 for x? What happens when I put in -2 for x? That's right, the denominator equals 0. If I plug in -2 plus 2, that's 0. I can't have 0 on the denominator, so x equals -2 is extraneous. That's why we got to plug it back into the original. All right, and then the next thing we do is we put 1 in, so we get 1 minus 1 over 1 plus 2 equals 1 squared plus 2 times 1 minus 3 over 1 plus 2. 1 minus 1 is 0. 0 divided by anything, let alone 3, is 0. 1 squared is 1. Plus 2 is 3. Minus 3 is 0. And 0 divided by anything, even 3, is 0. So x equals 1 checks out. Let's take a look at when I have 2 different denominators. So I'm going to go ahead and shorten this. Okay, so let's take a look at the second rational equation. I have a denominator of x plus 1 and a denominator of x plus 4. The least common denominator are those 2 items multiplied together. So the one that already has the x plus 1, I'm only going to multiply it by x plus 4 on the top and the bottom. Actually, no. I'm going to just go ahead and multiply both sides by the least common denominator. So we've got x plus 1, x plus 4 times x over x plus 1 plus 3 over x plus 4 equals x plus 1, x plus 4 times x plus 3 over x plus 4. Out of whiteboard. Okay. I don't know why in this problem they're all x's. If a y looks like an x, make it an x. Okay. So what that means is I'm going to distribute x plus 1 and x plus 4 to each of these terms inside the parentheses. So we get x plus 1, x plus 4 times x over x plus 1 plus x plus 1, x plus 4 times 3 over x plus 4 equals x plus 1 times x plus 4 times x plus 3 over x plus 4. So now the reason we did all this shenanigans is so we can cross out our common terms. So the x plus 1 and the x plus 1 cancel here. The x plus 4 and the x plus 4 cancel here. And the x plus 4 and the x plus 4 cancel here. So rewritten, I'm going to go ahead and distribute the x into the remaining term. And then the 3 into this one. And then I'm going to multiply these guys together. So x times x is x squared. X times 3 is 3x. 1 times x is 1x. And 1 times 3 is 3. Let's combine our like terms. So for us, that's these guys over here. So I get x squared plus 7x plus 3 equals x squared. 3 plus 1 is 4. 4x plus 3. We're going to go ahead and subtract everything on the right-hand side. So So we get 0 on one side, and we're going to subtract x squared. We're going to subtract 4x, and we're going to subtract 3. We get x squared minus x squared is 0. 7x minus 4x is 3x. 3 minus 3 is 0. We get 3x equals 0. Here's the test of your math acuteness. If 3x equals 0, what must x equal? 0. Because anything times 0 is 0. If I divide both sides by 3, we know 0 divided by 3 is 0. Now, we got a test. We don't have an extraneous solution this time around. So let's throw 0 in to all of these shenanigans and see if we get out an equivalent statement. So we got 0 over 0 plus 1, 3 over 0 plus 4, 0 plus 3 over 0 plus 4. 0 over 0 plus 1, this becomes 0. 3 over 0 plus 4 becomes 3 over 4. And 0 plus 3 over 0 plus 4 becomes 3 over 4. So this guy actually checks out. So x equals 0 is the solution. Right, we're going to talk real problems. Problem number 2, using rational equations. A flight across the U.S. takes longer east to west than it does west to east. Assume the winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane's speed. When flying eastward, the tailwind increases its speed. The time for a round trip shown at the right is 7 3/4 hours. If the airplane cruises at 480 miles per hour, what is the speed of the wind? Please recall, anytime we're doing distance, time, and speed, we want to use the rate times time equals distance. They're asking for the speed of the wind. That is also known as the rate. So we are going to divide both sides by. Airplane cruises at what is the speed of the wind? Well, I guess they solved for time. Time is equal to the distance times the rate. It doesn't matter, we're going to collect the distance, the rate, and the time for each trip. So, going east to west, the distance is the same. It's 1,850 miles. You can get that from the picture. And that does not change going back. The rate. We know that we're traveling at 480 miles per hour. We know that when we're going west to east, the wind speeds us up. Whatever the wind's going to speed us up. And then what does it do when we turn around and go the other way? It's going to slow us down, so we are going to minus it. So the time is it's the distance divided by the rate. Okay. So our total time is the time from west to east plus the time from east to west. So our total time for the round trip, that's this guy. Our round trip is 7 3/4. So we go. So we go 7.75 because 3/4 is 7.75 is equal to our total time going east to west plus our total time going west to east and plus our total time going east to west. We multiply by both sides by our common denominator. So the common denominator is 480 plus x times 480 minus x. Multiply everything by that, just like we did in the practice problem. So when we rewrite this, the 480 plus x and the 480 plus x will cancel out. The 480 minus x and the 480 minus x will cancel out. So you're just going to be left with 480 minus x times 1850 and 480 plus x times 1850. And then we're going to FOIL this guy. So let's go ahead and do the mathematics on the foiling. So once we multiply these guys through, we get 1,785,600 minus 7.75 squared. And then we're going to go ahead and FOIL each one of these. And we get 888,000 minus 1850x plus 888,000 plus 1850x. Looky here, we've got negative and positive, so those two cancel each other out. We're just going to add these two guys together. When we add 888,000 to 888,000 and then subtract 1,785,600 from both sides, we get negative 7.75 x squared equals negative 9,600. What do you guys think the next step is? So we are going to divide both sides by negative 7.75. We throw that in our calculator, negative 9,600 divided by negative 7.75, and then take the square root. We get x is either equal to positive 35 or negative 35. The wind speed is positive, so x equals 35. So the west to east wind speed is about 35 miles an hour. We're going to check to make sure that works for this problem. So we plug in 35 and we get 1850 divided by 480 plus 35 plus 1850 divided by 480 minus 35. That reduces down to 3.6 plus 4.2. And because we're rounding, look at our little approximation. You guys see the approximate. So 3 plus 4 is 7, and 0.6 plus 0.2 is 8. So this is about 7.8, which is about equal to 7.75. Not bad for rounding. So if we want to use a graphing calculator to solve a rational equation, we enter the left-hand side as y1, so underneath y1, and make sure we put the proper parentheses, and this works for our bracket utility as well, for Desmos. So we go 2, so it's parenthesis, 2 divided by x plus 2, close parenthesis, plus parenthesis, x divided by parenthesis, x minus 2, close parenthesis, close parenthesis. And then whatever's on the right-hand side, we put as y2. Okay. So once we get our equations in, we look at the graphs and press the graph button. And this shows up. There appears to be only one intersection point. When you're in your graphing calculator, you It's the original button is the trace button. It's right next to the graph button. It's got a little calc on top of it. It's one of the top right buttons. You press second and trace, and you can calculate the intersection. Then we take a look at the table. The table button is the same button as the graph button. You just press second and then graph. And y1 equals y2 when x is equal to 0. So x equals 0, y1 is 1, and y2 is also 1. That's it for today. That's it. Last one, guys. Take a moment and write your summary. Definitely include the first step to solving a rational equation expression. And how to use graphing to do that, and please include the distance equals rate times time problems so that we have that embedded in our memories. And that's it for today. We did